Hi guys. Today's topic is inverse trigonometric functions, sine inverse, cosine inverse, tangent inverse, those functions. What I will cover today is what is the inverse trigonometric functions? What is their domain? What is their range? What is the shape of their graph? After that, the domain range question, a sample, which is including the inverse trigonometric functions. Then the third one is the combination of the compound angle formula together with the inverse trigonometric questions. Yeah, I will cover all those things today. The first thing is what is the how the sine inverse function looks like? Y goes to be, for example, y goes to be sine inverse function. Before we proceed to the sine inverse function, what is the inverse function? You need to remember three things about the inverse function. The first one is inverse function is kind of new function, right? We have original function at the very beginning before we make the inverse function. Yeah, we are driving, we are able to drive the inverse function from our original function, right? How we can get the inverse function from the original function? Okay, we switch y and x and then make y the subject. Then that is the inverse function we have already get, right? But the problem is always coming from the domain and range. How we can get the domain of f inverse? That is coming from the range of the inverse, the original function. Where is the range of f inverse we can get? Yeah, that is coming from the domain of f inverse. So we can switch the domain and range of original function to get the domain and range of the inverse functions, right? I call this as a reset domain. So the first thing you should remember about the inverse function is, we need to reset the domain. Second thing, when the inverse function exists, if the original function is 1, 2, 1, then the inverse exists. We call this as existence. Yeah, the existence of inverse function. There is a condition for inverse function to be existing. Yeah, the original function must be one-to-one function so that we can test whether the inverse function exists or not by the horizontal line test. For your reference, yeah, what is the vertical line test for? Uh, whether the expression is functional or not, yeah, relation is functional or not, yeah. To test that, yeah, we use the vertical line test. But in order to test the existence of the certain function, the existence of the inverse function, we need to use the horizontal line test, right? The third thing about the inverse function is graphically. Yeah, this is y goes to be x symmetric with original function, right? So we have y is x function, x line, and this is, for example, y equals to be fx. Then this can be y equals to be f inverse x. Those two functions are y equals to be x symmetric. right? Okay, those three things you should remember about the inverse function. Then, okay, let's go back to the sine inverse function. Original sine function, if I draw here, then it should be something like this, right? And then if we check, okay, the horizontal line test, oh, we have so many intersections, so that there cannot be inverse function, right? But we need to have inverse function. That's the problem here. Originally, sine y goes to be sine x is not a one-to-one function, which means for a single value of y, we have multiple values of x. So that at this moment, as it is, yeah, right. If we want to make the inverse function, or that won't be the function, because for the one value of x, yeah, we have so many y values. If you can invert it, right? So how we do? We do domain restrict. We call this function as a domain restricted trigonometric function. For sine function, yeah, we restrict the domain from negative pi over 2 to the pi over 2. Then we can make, oh, this is one-to-one function, right? Then now we can draw the inverse function. Okay, how we draw? The domain is from pi over 2 to negative pi over 2. So once we convert this, the switch x and y, then okay, our range is from minus pi over 2 to pi over 2. The original function's range is from minus 1 to 1. So that once we switch the x and y, then inverse function has a domain between the minus 1 to 1, right? So I redraw that here. This much is 1, okay, 1, minus 1, minus 1, pi over 2, here pi over 2, here pi over 2, here negative pi over 2. Original function is inside this much. And then y goes to be x, function is here. This is y goes to be x, and the original sine x function is here. If I convert these, then domain goes to be range goes to be domain. The graph will be something like this. This is y goes to be sine inverse x. So the domain of y goes to be sine inverse x must be from minus 1 to 1. Range must be in, right? You should remember those two. Good. Yeah, this is the shape of sine inverse function. When we use those kind of sine inverse function at the very beginning, yeah, I can explain this. Whenever you need to solve this the trigonometric equation, yeah, then the sine inverse function, cosine, those inverse trigonometric function is very pretty much needed to get the answer at the end. Later, yeah, later part of the today's lesson, yeah, maybe I can explain that. Y goes to be cosine inverse x. That is the next one. For the same reason, cosine inverse x, we restrict our domain from not from the negative pi over 2 to pi over 2. Then still it is not the one-to-one function. In order to get the one-to-one function, yeah, we restrict the domain from 0 to pi. So where is it? Okay, from 0. Okay, this one is pi, let's say. And then 1 minus 1. we can restrict the original cosine function in this range. This is domain restricted. Y is cosine x. And where is y equals to be sine x? And no, y equals to be x first. Y equals to be x. Then we need to make the a symmetric drawing, right? From -1 to 1, from 0 to pi. You can draw around these blocks. And then here pi over 2. And then it goes from here to there. Like this. This is our cosine inverse x. The most, okay, we try to write down the domain range of this y goes to be cosine inverse x. Inverse x, domain of cosine inverse x is again -1 to 1, right? From -1 to 1, that is domain. The range y is in between, from 0 to pi. It's different from the sine inverse x, correct? But more importantly, yeah, here we need to remember this. This is what? Decreasing function. You should remember cosine inverse x is decreasing function. So that whenever we need to solve the inequality question involving the cosine inverse x, yeah, you should think twice. Okay, cosine inverse x is decreasing function, and then it's their domain and range. The last thing, okay, y goes to be tangent inverse x. What is the shape of tangent inverse x? Yeah, do we need to still restrict our domain? Yes, definitely. Where to where? Pi over 2 to negative pi over 2. Then our original tangent x function is here, right? Then how is the inverse function? This much is pi over 2 to negative pi over 2. Here we have the line, y is x, then the graph goes by this. This is y goes to be tangent inverse x. Okay, so again, the domain and range, y goes to be tangent inverse x. The domain, x is all real number, right? The range, y is in between minus pi over 2 to pi over 2. Yeah, those three things, those three graphs, yeah, you should keep in mind. Sine inverse, cosine inverse, and tangent inverse. The graph and the domain and the range. And then also, yeah, please keep in mind what kind of facts you should remember about the inverse function. The three things I said, right? We need to reset the domain. The range is coming from domain. Domain is coming from the range. The second thing, when the inverse function exists, yeah, one-to-one function. If the original, only if the original function is one-to-one, then we can say the inverse function is existing. Then graphically, the inverse function is the symmetry with the original function, right? Okay. Application. First, domain and range question. For example, what is the domain? Largest possible domain. Okay. How? Okay, the domain question. A few things you should remember. If the function is this form, then fx cannot be 0, right? Second, if fx is inside the square root, then fx must be bigger than or greater than or equal to 0. And third, if fx is inside the logarithmic function, then fx must be positive, right? If fx is on top of the exponential function, fx can be all real number. What else we have? Something like this. Okay, I cannot remember everything now at this moment because today's focus is the inverse trigonometric function. We return it back to here. Certain function is inside the square root, so that the first thing we can think is pi over 4 minus cosine inverse x must be what? Greater than or equal to 0, right? Then cosine inverse x is smaller than or equal to pi over 4. Oops, sorry. Then what is the next step? What is the next step? For any inequality the question, what you need to think is the graph. At this moment, okay, we remember that cosine inverse x is what? Decreasing function, right? We already know the shape of the cosine inverse x. So what we should do here is we should draw the curve. We should sketch the curve very briefly. Okay, this is cosine inverse x, let's say. And here we have pi over 2. Here we have pi. And then here, somewhere here, we have pi over 4. Right? And then cosine inverse x is, this is the first curve. Cosine inverse x. Huh? That should be smaller than this y goes to be pi over 4. Where is it? That is from here to there, right? This is our range of the solution from here to there. We already know this coordinate of x coordinate of this point is 1. What is x coordinate of this? That is okay. In order to get x coordinate of this, we should solve the equation which is cosine inverse x goes to be pi over 4. Oh, sorry, pi over 4. And then x is cosine pi over 4, which is square root 2 over 2, right? So here x is square root 2 over 2, and here we have x is 1. So that the solution is x is in between. A last student write this, okay, cosine inverse x is on the left side, and the right hand side, we can put cosine pi over 4. And then keep the sign of the inequality, and then say that this is the answer. No, definitely this is wrong. Okay, that's the difficulty of this inverse trigonometric function. Cosine, especially cosine inverse x, is the inverse function, and then the cosine inverse x has its own what? Domain. Since x is inside the cosine inverse x, just by this form, x must be between -1 and 1 only. X cannot be outside value, right? Within that range, we need to solve where cosine inverse x is smaller than pi over 4, so that there is this range. Okay, this is the first type of the question I can explain to you. Second thing, equation question. For example, cosine x goes to be negative 0.2. How to solve this? Cosine inverse. Okay, here cosine is positive, here cosine is positive, here cosine is negative, here cosine is negative, right? And then I can introduce the so-called reference angle. Reference angle x, no alpha. Alpha is actually, we ignore the positive or negative sign. We can calculate the acute angle cosine inverse of the same absolute value. Cosine inverse 0.2. This much. That is the so for the reference angle. Then actually x is where? X is here. The same amount of the angle, and then here same amount of the angle. Whenever we need to draw this the terminus, so-called the terminus, and then when we need to draw the angle with the x-axis always. We should draw the triangle with the x-axis always. Don't try to draw the triangle like this, right? Okay. Okay. Then how we can write the answer here? For example, if x is just within one revolution, then x can be pi minus alpha, pi plus alpha, right? Alpha is cosine inverse 0.2. If, for example, x is minus pi to pi, then x is minus pi plus alpha. How to read minus pi plus alpha, right? Another one is pi minus alpha. How to read that? Plus pi minus alpha, right? That's the way we are reading the angles, right? So whenever you are solving the trigonometric equations, first you should consider what is the reference angle, which is acute. Ignore plus or minus sign, then get from inverse trig function like this, right? After that, yeah, from the unit circle or the xy the plane, yeah, which quadrant the angle should be, because cosine is negative, it should be in Q3 and Q4, right? You draw a triangle with the x-axis, and then this line, the terminal here is pi, right? So the pi minus and pi plus. Or yeah, this one is minus pi, so that yeah, this terminal can be read like minus pi plus something like that. Okay, that is the second application. That is the equation. You can use a lot the inverse trigonometric functions, right? The third thing, the third example is a simple question like, okay, for example, sine inverse 0.5 is what? The answer is 0.5, right? Sine inverse of sine of pi over 6 is what? There's still pi over 6, correct? Then the next question is, okay, sine of sine inverse 1.2 is what? It's undefined. Because this value must be within minus 1 and 1, and that it is out of the range, that's why this entire function cannot be defined. Then the next one is most important and then difficult. What is that? Sine inverse of sine of, for example, which one you should do? 7 pi over 6. What is the answer? The answer is negative pi over 6. Why? Why? Okay, let me explain this why. Sine function is, I think I will explain this way. Here we have pi, here we have 3 pi over 2, and then 7 pi over 6 is here. Right? So in order to get this value, we should read y value in this way, right? And then we know that this is negative half. After that, then the next step is, okay, what is the sine inverse negative half, right? And this step is important. What? When you read the sine inverse function from here, then what you should do is you should use the domain restricted sine function. Here we have domain restricted sine function. And then in order to get the sine inverse, instead of going back along this yellow color line, here we should go along this way. Because sine inverse function has been defined within this blue color curve on here. That's why one-to-one relation is very important. And then this one, if you use your calculator to calculate, then you can check. This is negative pi over 6. Okay, this is the to get the sine inverse of negative half. Then, how about this case? Yeah, of course, sine pi over 6 is within this range, minus pi over 2 to pi over 2, so that this one will appear here as the same form. Am I right? But the value inside here is out of the range between the minus pi over 2 to pi over 2. Then you should think about the curve, and then what is the domain restricted sine curve. When we read the value for sine inverse x, we should consider all the values within this blue color line, blue color curve. Okay, this is another thing. Of course, the similar questions can be uh, uh, with the cosine functions and tangent functions, everything. Yeah, but I won't cover all of them here today. The last one is combination between the compound angle formula. What is the compound angle formula? Compound angle formula is this one, right? Sine A plus B equals to be C C cosine A plus B co C, right? Tangent those three we call that as compound angle formula, right? What is the question? So, what is the value? This is the question, right? Okay. Inverse function, tangent inverse half is actually what? This is actually angle, right? And this much is also angle. So that let alpha be the tangent inverse half, beta be the tangent inverse 1 over 3. Then what we need to calculate is alpha plus beta, angle plus angle, right? So instead of just by calculating the angle plus angle, we just take the tangent of those angle sum, tangent alpha plus beta. Then how we can calculate this? 1 minus tangent alpha tangent beta tangent alpha plus tangent beta, right? Do we know what is the tangent alpha and tangent beta? Yes, here. Since we let alpha is tangent inverse half, so that tangent alpha is half, right? Tangent beta goes to be 1 over 3, correct? And we have all the values here, 1 minus half, 1, 3, 1 over 2, 1 over 3, which is actually 1. Then, as a conclusion, what we have here is tangent alpha plus beta goes to be 1. Then, Now, in order to find the value of alpha plus beta, we need to solve this trigonometric equation. Tangent is 1. Where is the terminal? Oh, the terminal is here, right? Pi over 4. We have another terminal here as well. Of course, this angle is the same with this. Pi over 4, 3 pi over 4, 5 pi over 4, blah blah, and then negative 3 pi over 4, blah blah. Yeah, we have so many different values, but among all of them, which one is the answer? For this, yeah, we need to know what is the range of tangent inverse function. Since the range of y equals to be tangent inverse x is what? 18 minus pi over 2 to pi over 2, right? So that we can say that alpha is also in between minus pi over 2 to pi over 2. Then beta is also between minus pi over 2 and pi over 2, right? And then, please, okay. My computer goes to be slowed down. I need to finish this as quick as possible. Since, okay, and also alpha A needs to be positive because alpha is tangent inverse half. That is positive, right? Correct. And from the graph, if x is positive, then y is also positive, right? So the alpha is positive. Beta is also positive, which means alpha plus beta is positive. That's why from all this information, alpha plus beta must be within 0 to pi, right? So within this 0 to pi, tangent inverse, tangent goes to be 1. That's why alpha plus beta goes to be pi over 4, right? This is one of the very famous questions. A similar question can be here. Tangent inverse 2, tangent inverse 3. You can try this. Then if I will make one question by myself, then I can create yeah, you can try to solve this as well. If you can solve those two questions, then that would be already good enough for this fourth example. Combination between the compound angle formula with the inverse trigonometric functions. Okay, today what I have done is four things. The first one, I gave you the shape of the trigonometry inverse trigonometric functions, right? The domain restricted from the domain restriction of the sine function, cosine function, we can get the inverse functions, right? And then the first example is about the domain array. Sorry, the first example is about the domain and range. You should know the most important thing is you should be aware of what cosine inverse x is decreasing function. Don't forget about it. And then the second one, okay, for whenever we solve the trigonometric equation, yeah, we use the inverse trigonometric functions as a reference angle. So in that case, only we use the acute angle, right? And then the third one is yeah, there are some tricks. The f sine inverse of sine of 7 pi over 6, those kind of questions. Yeah, you should consider where is the domain restriction so that we can get the correct answer. Yeah, those things. And then the last one was the very typical question from the IB exam, especially tangent inverse half plus tangent inverse 1 over 3. How we can get a solution. Yeah, I have covered all those things. Yeah, today I did the inverse trigonometric function. Okay, see you tomorrow. Bye.